Welcome back, Math Lovers. So today I got a very interesting question. Question is the number of ways of selecting two numbers from the set 1, 2, 3, so on till 12, whose sum is divisible by 3. So you can understand here, this set of 12 numbers can be categorized easily into three groups. One is a group of three multiples, where you will have 3, 6, 9, and 12. The other is a group of 3 multiple plus 1 type. That is like where you will find 1, 4, 7, and 10. And you'll find other group of 3m plus 2, 3 multiple plus 2, where you will have 2, 5, 8, and 11. So now if you pick two numbers, and then their sum has to be divisible by 3, there are only two ways to do this. Either case 1, pick two numbers from the list of 3 multiples. So that will be, there are 4 numbers in that group, so it will going to be 4c2. The value of 4c2 will be 6. We can expand and see using n factorial by r factorial into n minus r factorial formula. Case 2, you can pick one number from the list of 3 multiple plus 1 and one number from the list of 3 multiple plus 2. So when you add them up, it will become 3m plus 1 plus 3m plus 2 type. It will give you a 3m plus 3, which is again a 3 multiple. So there are 4 numbers in that list and 4 numbers in this list. So you're going to pick one number from them each and their product, because they are happening independently. So whatever number you pick from the first 3m plus 1 column does not matter to what number you're picking from the 3m plus 2 column. So 4c1 value will be 4. So it's 4 into 4, 16. So both the cases are success for us. So we need to add both the number of ways there. So this 6 ways, the 16 ways have to be added to give us the total number of success ways. So the answer will be 6 plus 16, which will be totally 22 ways. Okay. I hope this question was interesting. I got one more interesting observatory question today. Question 2. The question is total number of selections of at least one thing and at most r things from 2r plus 1 different things is 255. Find the value of r is our question. Okay. So see the beauty here. So this 2r plus 1 is like an odd number, right? 2 multiple plus 1 is like an odd number. So I wish to recall the Pascal triangle here. We'll also see the every odd row, how it behaves. I'm rewriting the Pascal triangle for you. So in Pascal triangle, we know this is called a zeroth row, first row, second row, third row, fourth row, and fifth row, so on. So notice in every odd row, there are even number of elements. For example, in third row, you can identify which is there are 4 elements, and if you equally divide them or symmetrically divide them, then the sum will be same also. 1 plus 3 is 4, 3 plus 1 is 4. This is the fifth row. Again, you can symmetrically divide them. You'll get 1 plus 5 plus 10, which is 16, which is same as 10 plus 5 plus 1. And we also learned in the Pascal triangle video that is every row, it will be the elements will be adding up to the power of 2 power n, that row number. So then if you see half of it, then it will be half of 2 power n. So creating 2 power n minus 1. So let's see what happens here. So according to them, they have to select at least one thing from 2R plus one thing. So from 2R plus one, they are selecting, like say, one thing. This is a success case. From 2R plus one things, let's say they are selecting two things. So like this, everything is a success thing until they are going to reach selecting R things. 2R plus 1 C R. So that's what the system is here. So according to them, this value is 255. We can notice there is one particular thing missed here at the start. So there could be a way of selecting zero things also. That is 2R plus 1 C0. If you want, we can insert, add and subtract it. Okay. And as per the identification, like say, I was saying this is the fifth row. So this is like 5C0. This is 5C1. This is 5C2. This is 5C3. This is 5C4. This is 5C5. So this 5 at the top is the row number. So in that row number only, in our question, we have 2R plus 1. So if 5 is 2R plus 1, so from that we understand, if 5 is 2R plus 1, from that we understand, so R value has to be 2. So exactly at the midway, until the rth position is going to give us the half of that row, correct? So 2R plus 1 C0, 2R plus 1 C1. So until 2R plus 1 CR will be exactly half of that row followed by the second half. So as I already told you, what we are missing here is, we are just missing the 2R plus 1 C0 term. Okay, so I wish to add and subtract that. I'm going to add 2R plus 1 C0 term to the both the sides of the equation. So 2R plus 1 C0's value will be just 1. So 255 plus 1 will make it 256. And now since this is going to be half of that particular row, so as I told you, the result will be half of 2 raised to the power of that row number, 2 to the power of 2R plus 1. So let's see what happens. So if we take this by 2, that side will become 512. So 2 power 2R plus 1 is 512. We all know what is 512. It is 2 power 9. So let's compare the powers. If 2R plus 1 is equal to 9, so 2R will be equal to 8. So from that we get the value of R. R will be equal to 4. Hope you enjoyed this visual observation from Pascal triangle one more time. So like, share and subscribe. Thank you people.